One of the fundamental pieces of military equipment is the infantryman and his rifle. Throughout the history of firearms, the soldier's musket was the crucial piece of hardware in gaining ground and holding it, effectively winning the battle. Despite advances in weapon ignition systems culminating in the percussion cap, all firearms suffered from the same drawback of muzzle loading. By the time of the percussion cap, most armies had modified their stock of flintlock rifles or purchased new percussion designs. Attempts had been made over the years to improve this situation, and many samples of breech-loading weapons exist. Henry VIII had a fine example of a pair of wheel-lock pistols that were breech-loading. Samples of wheel-lock and flintlock muskets with this unique system abound. One of the main reasons they were not successful was due to their cost, and often the escape of gases from the chamber made them sometimes less than reliable. One attempt involved a British designer, Frederick Prince. In 1855, his bolt-action design was manufactured. A bolt protruded from the barrel that allowed the entire barrel to be unlocked and slid forward, allowing access to the breech. Another design was the Ferguson rifle. The Ferguson rifle had a short but distinguished life. A half-turn threaded plug at the back of the barrel could be quickly removed and the weapon loaded, sealed and ready to fire with the conventional flintlock. 100 rifles were ordered and an infantry company formed that fought in America. Breech-loading designs proliferated. 1819 saw the United States the first country to adopt a breech-loading rifle as the principal infantry weapon, the M1819 Hall rifle. The rear breech could be raised up and charged with bullet and powder, then dropped into position ready to fire with a cap and percussion lock. A flintlock version was also manufactured. In 1812, Swiss gunmaker Samuel Johannes Pauli, who had served in the Swiss artillery, took out a patent on a new breech-loading mechanism. The break-action mechanism was not new, but in combination with a new cartridge design was outstanding. The design incorporated a wooden or brass base with a recess in the center, where a cap or pellet was placed. The base was slightly tapered, as to the breech, allowing for a snug fit of the cartridge base. This sealed the chamber, keeping gases from escaping. Secured to the base was a paper tube, into which went powder and shot or ball. A firing pin was housed within the mechanism. In effect, Pauli had developed the first shotgun cartridge. Another avenue of development, led by J.N. von Dreyse, was the so-called needle gun. In 1827, the Dreyse breech loader was developed. A bolt was drawn back, revealing the breech. A special paper cartridge consisting of bullet, powder, and an igniter or fulminate cap set at the base of the bullet was inserted, and the breech closed with the bolt action. To fire, a spring-loaded needle would pierce the paper cartridge and strike the primer cap behind the bullet, firing the shot. It was so successful that the Prussian army adopted the weapon in 1840, and it saw active service in 3 consecutive wars against Denmark, Austria, and France. The needle gun had 2 drawbacks. One, the breech did not always seal correctly, allowing the escape of gas. And since the needle must reside inside the cartridge as it burns, the needle was subject to extreme heat and corrosion from the powder, often breaking or warping. However, the bolt action enabled riflemen to remain prone and concealed while reloading, a development not lost on the opposition, who also looked to adopting breech-loading technology. The British developed the Snider rifle from the earlier Enfield rifled musket of 1853. It had better breech sealing, and the angled pin was less likely to fracture. The French developed the Chassepot rifle in 1866. It was an improved Dreyse design, which included the automatic cocking of the firing pin as the bolt was closed. The modern all-metal cartridge was not far away. In 1855, a patent was taken out by Clément Potet for a cartridge with a metal base, a percussion cap set in the center resting against an anvil. A firing pin would strike the cap and crush it against the anvil, igniting the charge. The flame would enter the body through vent holes, firing the main charge. 3 years later, a similar design by François Schneider was purchased by British gunmaker George Daw and received a patent in 1861. At the Royal Woolwich Laboratory in London, Colonel Edward Boxer combined the Schneider-designed metal base and primer with a coiled brass body cartridge. The brass was flexible enough to expand and completely seal the breech as the powder burned. The year was 1866. It took another year before the process of constructing the entire case from one piece of brass was accomplished. But the breakthrough was made, and a rifleman could carry his ammunition in one complete unit, weatherproof and reliable. He could load his weapon with ease and could increase his rate of fire tenfold. Few realized at first what a leap forward the modern cartridge was, for it would allow the development of self-loading and eventually fully automatic weapons. The breech-loading rifle was quickly adapted to take the Boxer cartridge. The race was now on to fit the rifle with a supply of the new ammunition, a magazine to speed up the cyclic rate of loading and firing. Magazines were not a new idea. Many early designs going back to flintlock had been tried. One of the more successful was by Walter Hunt, a prolific inventor who also designed self-contained hollowed-out bullets with the powder charge sealed inside. He developed a 12-round tubular magazine and feed system he called the volitional repeater. The mechanism was too complex and flawed to be practical, but Lewis Jennings took over the design and in 1849 received a patent for his major alteration, which was to make it a lever-action mechanism. And this caught the eye of two American gun makers, Daniel Wesson and Horace Smith. Smith and Wesson had teamed up in 1852 to produce the volcanic pistol. Their company was called the Volcanic Repeating Arms Company. They also took on the lever-action repeating rifle design. They met with limited success with the caseless ammunition. The company went bankrupt. A shirt manufacturer by the name of Oliver F. Winchester took over the company and renamed it the New Haven Arms Company. Dan Wesson set about designing a rimfire cartridge to solve their engineering problems. Benjamin Tyler Henry joined the company and quickly set about perfecting Wesson's rimfire bullet. He redesigned the volcanic lever action, retaining the tubular magazine and breech mechanism. The .44 caliber Henry rifle of 1860 was born. Never officially adopted by the Army, the Henry was ordered by many Union officers and soldiers during the American Civil War. The 16-round weapon was disdained by the Confederates, who were quoted as saying that damn Yankee rifle that they load on Sunday and shoot all week. Another rifle designed with the rimfire cartridge was the Spencer repeating rifle. Christopher Spencer based the design on the Dreise breech loader with the tubular magazine in the butt of the rifle. After loading the breech with a lever action, the hammer had to be cocked manually. After an audience with President Lincoln, Spencer gave a demonstration, whereafter the gun was put into production and adopted by the Union Navy and Army. It saw action in the Civil War. After the war, Oliver Winchester renamed his business the Winchester Repeating Arms Company and set about redesigning Henry's rifle. The 1866 model Winchester lever-action rifle had numerous improvements, including the side-loading port and wooden forearm. It fired the same rimfire .44 caliber ammunition. The 1873 Winchester went on to become the gun that won the West. Chambered with a center-fire pistol cartridge, .44-40 and other pistol calibers, it wasn't until the 1876 Centenary model that it was chambered for a full-powered rifle cartridge. Many more models of the popular Winchester lever-action